In this video, we're going to discuss what are called dot products of vectors. Dot products is a form of multiplication we can do with vectors. We take two vectors as the input, and the output of a dot product will always be a scalar quantity. We call it the dot product because the symbol that we'll use for the operation is a dot. Sometimes it's also called a scalar product because it does give us a scalar as a result. In this video, we'll define how it's done geometrically. In the next video, we'll look at how we actually compute it in terms of components of a vector. So if I want to talk about the geometric definition of the dot product, the first thing we need to do is talk about the angle between two vectors. So here I've drawn my two vectors that we're going to take the dot product of. I've drawn u and v. I'm assuming they're non-zero vectors. And as such, I should be able to measure some sort of angle between those two vectors. Even in 3D, I can measure that angle between them, and I'm going to call that angle theta. But we need to be precise here. When I say the angle between two vectors, I mean measure it in a sensible way. Take the smallest positive angle that gets you rotation from one to the other. What you wouldn't take as the angle between them is this big angle going around the other way, or some angle that's coterminal to it with lots of extra rotation. So by the angle between two vectors, we're going to call that theta in the picture. We mean the smallest positive angle between 0 and pi radians. Or if you prefer degrees, between 0 and 180 degrees. It's now possible to define the dot product of u and v geometrically. So we write u dot v. We never omit that symbol. So the dot there is just necessary if you want to compute a dot product. And it's defined as the length of u times the length of v. So this makes sense. You probably want the scalar to be impacted by the lengths of the vector. And then we're going to multiply those by the cosine of the angle between them. So this formula here is the geometric definition of the dot product. Note on the right-hand side, I have two vectors going into this expression, and the output over here is a scalar quantity. It's worth just drawing a graph of the cosine of theta between 0 and pi as we do some calculations. So notice at 0, the cosine starts at 1. At pi over 2, or 90 degrees, it's 0. And then at pi, or 180 degrees, it hits its low value of -1. But we see the entire range of values that cosine can attain between -1 and 1 on this interval 0 to pi. So let's do an example. I'm going to start with the vector u. And that vector is going to be square root of 2, square root of 2. So you can imagine here, I've drawn the unit circle for perspective, but this is going to be a vector that has length 2. And if I calculate the length, you can check that. I square up both of these components. I get 2 plus 2. I take the square root of their sum. Square root of 4 is 2, so the length is 2. My second vector is v is going to be 0, -1. So it's going to point to this point on the unit circle. And of course, its length is 1. That's a unit vector. I can now measure the angle between them. And so I'm going to find that smallest amount of positive rotation that gets me from one to the other. And that's going to be 3 pi over 4. So u dot v now is the length of u, which is 2. The length of v, which is 1. And then I multiply by the cosine of 3 pi over 4. Cosine of 3 pi over 4, well, that's over here in this quadrant between pi over 2 and pi, and so that's going to be some negative number. It's going to be negative root 2 over 2. The 2's will cancel, and I get negative square root of 2. So the dot product of u and v is minus square root of 2, the scalar quantity. Now, what does it mean? Well, at least at a very superficial level, we can see that the sign of the dot product is negative. U dot v is less than 0. And that's an indication that the angle that you're working with is over here. And so that just means that the angle theta is an obtuse angle. It's a big angle. Theta is between pi over 2 and pi, between 90 and 180 degrees. So a negative dot product indicates that the angle is obtuse. Let's take the vector I now. So I've drawn that in the picture. That's the unit vector 1, 0 in 2 dimensions, pointing to this point on the x-axis on the unit circle. And then we measure the angle between, let's do u dot I. So I'm going to measure the angle between u and I. That's 45 degrees or pi over 4. And so our dot product is going to be length of u, which is 2, length of I is 1, and cosine of pi over 4. Pi over 4 is in the first quadrant. It's over here where the cosine is positive. And so this is going to be 2 times 1 times the positive square root of 2. And we get square root of 2 for the dot product. So similarly, as we saw before, negative dot product meant an obtuse angle. Now that I get a positive number for u dot I, that tells me that my angle is acute. That means an angle between 0 and pi over 2, between 0 and 90 degrees. If I look at I dot V, so here's I, here's V, the angle between them is pi over 2 now. So the length of each one is 1, and I multiply by the cosine of pi over 2. Cosine of pi over 2 is 0. So that's just an indication that these two vectors are at a right angle to each other. I dot V will give me 0 in this case. So if I have two non-zero vectors and I take their dot product and I get 0, that tells me the angle between them is pi over 2. If I take any of my vectors to be the 0 vector, we didn't really discuss that in the picture. It doesn't really make sense to measure the angle between a 0 vector. But we will just define that to be the 0 scalar. And that makes sense. If one of my vectors has 0 length, who cares about what the angle between them is? That will make this product 0. So u dot 0, where u is really any vector, will always be 0, the scalar 0. I'm being very careful here. Arrow 0, meaning vector 0. No arrow over here, scalar 0. The next thing we should consider is what happens when we take a vector u and we dot it with itself. How do we interpret that result? So what is u dot u equal to? So we go to the definition and we just replace v with u. We'll have the length of u times the length of u. And then the angle between a vector and itself, if I just imagine closing this and replacing v with u, the angle between them will be 0. So cosine of 0 is equal to 1. So if I take the vector and I dot it with itself, I'm going to get the length of itself times the length of itself times 1. It will be the square of the length of the vector. So u dot u will get me the squared length of the vector. If you actually want the length, then you take the square root of the dot product. So the length of u is the square root of its dot product.